Okay, good afternoon, everyone. What I'd like to do in the next hour or so, hopefully a lot less because I don't want to have to sit here for another hour. It's cold out here. We're going to take a look at two virtual labs that were in this week's packet. And if you're looking in your materials for the week, it should be the last couple of things on here. One is called Lenses Virtual Lab, and one is called Bending Light Lab. Both of these apply to different things having to do with light being refracted either through lenses or when light is moving from one kind of medium to another. And we can really take these in whichever order. What I thought I would do is I would start you on one and give you a few info bits and answer any questions, and then maybe start you on another one and do the same. And then just field any questions, whether they're directly over these labs or whether they're over something else in this week's packet that you've got questions on. I'll go ahead and warn you ahead of time. The lab having to do with virtual lab using PhET geometric optics, this one here, it runs in Flash. So that shouldn't be a problem if you can turn Flash on your Chromebooks or on your computers. As far as I know, Flash doesn't work like on iPhones or iPads or Android phones or anything like that. The other one here, the Bending Light Lab, it runs in HTML5, so it should run fine on whatever gadget you want to do it on. I think what we're going to do is we're going to start with this virtual lab here. So I'm going to go ahead and run this in Flash. What do you mean no Flash player was detected? You're kidding me. I turned this on the other day. Yes. That would be great. This is ridiculous. Okay. So let me get my paper. As far as these go, if you want to print a copy out and do this on, just take pictures or scan it and send it back to turn it in, that's fine. If you want to work right in your Google Docs, that's also fine. If you have any troubles with any of that, feel free to ask questions and I'll see if I can help straighten you out on that. On this first one right here, let me go my directions. Okay, now for this one, you are going to legitimately need an actual honest-to-goodness ruler. There's a little built-in ruler in the simulation, but it doesn't work with what you're going to need. So you're going to need to track down a ruler or use a piece of paper and measure things out and then take it and find a ruler later. But you're going to need this to do this lab. It says to go to PhET simulations, pull up that particular sim, take some time to play with it and see how it works. Okay, so let's just go take a look at the lab real quick. Okay, if I'm cutting out, try something, and I'm going to type this too. Try to turn off your broadcasting video, okay? Try and put it where you are broadcasting audio, or since you're muted, just see and hear stuff, but if you hopefully help with some of the cutting out issues. Okay, good deal. So I'm going to take, okay. So I see as I move this pencil that the image that's being projected on the other side is also moving. As I move it closer, looks like it's getting bigger. If I move it smaller, if I move it past this right, it looks like my image vanishes. That could just be because my monitor is not big enough. How this is going to work. It also says I can change my object. For our purposes, we're going to want to change the object to the yellow arrow, I think is what it says in the lab. Virtual, let me turn that on. There we go. That's where it went. Okay. So let's get back to our paper. Oh, Jaren's saying it no work. Jaren, are you talking about, I'm still slightly cutting out and the screen is lagging a slight bit. Folks, I don't know what I can tell you as far as that goes. I'm going to be videoing the whole thing, so if it's just coming through way too choppy for you, your best bet might be to just wait and watch the video. Okay? It's just tech limitations. We're just going to have to bear with. So coming back over to my paper here, it says we're going to be moving the object to analyze how images are formed. I need to make sure my settings are as follows. I need to make sure, and it might be kind of hard to read on your copy, curvature radius is set to 0.8, refractive index is 1.53, and diameter is 0.8. I think that's a little bit easier to see on here. I need to do principal rays, 0.8, 1.53, and 0.8. So let's see if that's what I've got. Principal rays, 0.8, 1.53, and 0.8. And I'm going to turn virtual image off. Okay. So I maximize my screen using the ruler, measure the distance from X to the center line of my lens, recorded in data table 1 as F, and then double this value and record as 2F. Since everybody's got a little bit different monitor, it's going to look different for different people. I'm going to use centimeters because it's science class and I'm a nerd like that. On my monitor, I'm getting a distance from the X to the lens right at 6.5 centimeters. So I'm going to come down to my data table, focal length. Now remember, yours might vary. I'm going to put for my focal length 6.5 cm. If I double that focal length, 2 times 6.5 is going to be 13 centimeters. Let's see what my directions say. It says, using the ruler measure, okay, did that. Measure the height of the object and record. So, measure the height of object HO and record. Let's go back over to my sim. Okay, so my object's right here. You know what? Let me pull up a ruler and see just how close it actually is. Okay. Yeah, side difference. So Dilton ruler, that's garbage. So I want to measure how high this object right here is. And so again, I'm going to put my ruler right up next to my monitor. I might need to move it so I can get it in there. It looks like for me, it's weighing in at something like 3.5 centimeters. Record that on my table. Again, it's extremely unlikely that your numbers are going to be the same as my numbers, so don't go by what mine are telling me. Go by what you measure when you put a ruler right up on the screen of your computer or whatever it is that you're doing this on. So now let's see our other directions. Place the yellow arrow beyond 2F. In data table 2, record the distance of the object, distance of the image, height of my image, and my observations. Okay. So let me get my sim pulled back up here. So it says I need to take this out beyond 2F. So there's F. I'm going to assume that this is out beyond 2 times my focal. And so it says it wants me to find the distance of my object. So I'm going to take my ruler. I'm going to measure. I think I'm going to try and measure from like the midpoint of my object to the midpoint of my lens. Okay. Well, that's inches. That's not going to help. Okay. I'm going to call that about 17.5 centimeters. Again, yours might be different, so don't use my numbers. It wants to know the distance of the image. So without moving anything, I'm going to come in here and I'm going to use my ruler to measure from the midpoint of the lens to the midpoint of my image. And it looks like I'm getting about not quite 10.5, and I'm going to call it 10.5 just to kind of keep things simple here. So 10.5 centimeters. I need to measure the height of my object, height of my image. So take my ruler, and from the top to the bottom, I'm getting about 2.2 centimeters. Now, I need to talk about type of image, real, none, or virtual. So let's take a look at this. First of all, what I'm seeing here is that light rays that are coming from my object are being refracted. They are intercepting at this point right here. Anytime that real light rays are intercepting to make an image, that image is a real image. What exactly am I measuring for height? Okay. I'm using a ruler that I've got in my hand, and I'm taking it. Can I turn this thing? Of course I can't turn this thing. That's useless. Let me see if it'll let me draw here. Maybe. Okay, let me do like red. For height of my image, I'm measuring from this point to this point. So I'm measuring this right here. I'm sorry that that's not straight up and down, but I'm trying to write with a mouse and it's tricky. Distance for my image, I'm measuring from here over to here. For like distance of my object, I'm measuring from the mid of my here to my, okay. So since these are actually crossing, it's making a real image. And then on my paper, I need to report, okay, real image. Okay, direction of image, it's inverted because my object is pointing up, my image is pointing down, so I'm going to write inverted. And then it's going to have me continue to move my object to these different distances. I'm going to put it right at 2F. I'm going to put it between 2F and F. I'm going to put it at F. Then I'm going to put it between F and the lens. And then I'm going to report on all of these different things that I'm measuring. That's going to get me through the first part. Now for the second part, I'm going to be going to a simulation. If you look on your directions when you get over to page 2, let me get over to page 2 here. It wants you to go to the physics classroom. It wants you to follow this Google link. So I'm going to see if it'll let me do that real quick. Oh, goody. Go ahead and close up this other. Okay. It tells me in my directions. Let me jump back to my directions here. Okay, go to the following interactive, choose diverging lens, concave, place an object at 2F, record F, D, O, D, I, H, I, and H, O, kind of like I did earlier. I think I'm going to need to use my own ruler. There might be a ruler. Let's go take a look at it. Okay, so let me hit this button to blow this dude up. Okay. So it says choose diverging lens. Okay, there's diverging lens. It says to place my chosen object at 2F. So I'm going to use an arrow. I'm going to place it at 2F. My focal length. I'm going to record distance of my object, which is going to be this right here. And record distance of my image, which right down there. Check him out. Little bitty. Height of my image and height of my object into trial 1, and then I'm going to put it at F. And I'm going to record all those other things 2. So that part's going to go very quickly. After I play with that lens, I just have to move my object to 2 different places and record all of this information, kind of like I did up in the big one up here. Then on page 3, it's got some questions that go along with that. So I will tell you that this last question down here, where it says to research 2 basic types of vision problems, farsightedness and nearsightedness, if you look in the slideshow that I attached to this week's stuff, I believe it's, let me escape from that. I've got some cats that are getting in a fight right outside my door right now, and that's really fun to listen to. This chapter 14, lenses and refraction, it's got a few slides talking about lenses that are used in nearsightedness and farsightedness prescriptions, and so that might come in handy when you're doing that problem right there. Before we take a look at the other sim, which is actually going to go probably a lot faster than this one, anyone who's still around, do you have any questions? I'll go ahead and unmute. Okay. Anybody out there have any questions? Okay. Like everybody is remuting, so I'm going to assume no, you're good. I don't know if you can hear the cats freaking out. Here, hold on. I'm going to go kick my garage door and freak them out. I'll be right back. Just a second. Okay, cats got quiet. I made a dog across the alley start barking, though, so, you know, I guess you can't win. Now we're going to take a look at this bending light lab. Let me close up the virtual lenses tab here so I don't have too much stuff running on my computer. So we're going to be looking at this simulator right here. This one I think is a lot more fun, and it also runs a lot more smoothly. So you open the sim up, it runs in HTML5. You can go over to my paper copy. And here it was. So I get into bending light. I'm going to go over to my paper, and it says that when the simulator window opens, you should notice a laser pointing at a 45-degree angle downwards to the right. So I'm assuming they want us to click on the intro thing here. Okay, so check this sim out. Laser, I can turn on and off. I can use my protractor, kind of check coming in at, And looks like here, so it's coming in right at 45. It says to look to the right of the window and notice the two information boxes media that are shown on the screen. So what are the two media on the simulator window? Top one, the light is starting out in air. That's my first medium. And it is moving into my second medium. So coming over to my paper, what are the two media on the simulator window currently? I'm going to say air and water. Okay, I'll click on the red button in the laser. What two things does the light do as it hits the surface of the water? Well, I kind of already cheated on that. But let's take a look here. Well, it looks like some is reflected off, and if you look here, the angle of reflection, what we already know about reflection, if you're reflecting something off a smooth surface, it's going to be reflected at the same angle. It's being refracted, it's passing from one end to the other, and if you look here, the angle's changed. So coming back over to this, I'm going to say that the two things it does, it is reflected and some is refracted. Or I might say some bounces off the water, some passes into the water, but the angle changes. On the bottom left side of the sim, you should notice you have two tools available for you to use. Select the bottom tool that looks like a magnifying glass and move the tool into the general water area. Okay. So let's put up our protractor. Here's this. Let's move this into the general water area. Okay. Take the lens and drag it directly over the light coming from the laser before it hits the surface of intensity. Start filling in my table. It wants to know what's the light of the beam before it hits the surface of the water. I'm going to say 100% intensity. And it wants me to move it to the beam of light in the water. So I'm going to move it down to light that's in the water. I'm getting 94.71% intensity. So I'm going to record that. 94.71%. And then it wants to know the beam of light being reflected off the surface. I'm willing to bet that it's going to be somewhere around 5.29%. Let's see. Heck. I just took 100 minus the other one. So it looks like all of that light, if you total it up, of the light being reflected and the light that's being refracted, still totals up to 100% of whatever you started with as far as intensity. Now for the next several parts, it's going to have me put the protractor up there, and it's going to have me change the angle that the laser's coming in. And as I change the angle that the laser's coming in, I'm going to, again, take measurements of light intensity. Okay, Cambria had to go to a doctor's appointment. No problem. No worries. Okay, so it says right here to verify that it's coming in at a 45-degree angle. I did that a minute ago. Step 7 wants me to move the laser pointer, so I changed the angle of incoming light to where it's only 10 degrees to the left of the 0 mark on the vertical dotted line. So let's come in here and do that. Let me get rid of my little intensity meter here. Move him out of the way. Protractor. We'll get him right there in the middle to where it's coming in at the 10 degrees. So 30, 20, 10. 10 is going to be. I'm going to go through and measure all those again. So intensity before it hits is I need to know the beam of light in the water. Let's check its intensity. 97.89, that's different. Now, if I had to guess, I would say that my percent being reflected off is going to be about 2.11, but let's check and see if that's the case. So let's get my reflected light beam here. 2.11%. Absolutely correct. Okay. And then the rest of the lab just has you continuing. It has you do that again, only this time you're going to do it at 80 degrees. There's a couple of questions that go along with that first part of the lab. And then here it wants you to bring the laser so it's shining directly down onto the surface of the water. And it will have us fill out what percent of light enters and what percent is reflected back. And then once we get to part 11, what it's going to have us do is it's going to have us change the media. So we're starting off with air and water, and then we're going to be able to change it to air and glass. So let me go back to the sim and kind of show you how that's going to work. Let me turn off my laser, put up my toys here. So I've got air and water. If I change it, say, to air and glass, on, that's going to give me some slightly, let me change this back to water so I can get it. Let me bring my protractor up to see if I can make it a little bit easier. So put this at 60. So right now, as it's being refracted in water, it's being refracted at pretty close to 35, but if I change water to glass, and it makes it, wait, was that 35? Math. Oops. So it's close to 40. If I change it to glass, then it to just 35. And so on my paper, what I would do is I would sketch in these four boxes. Okay, so let's say that I've got the laser coming in right here, and I'm going to kind of put that it's being refracted and some is bouncing away. And I might even write in my angle right here, that my angle is like about 40 degrees. If this angle right here is about 60 degrees. And then when I do my air and glass, I'm going to keep this at 60 degrees up here, but this refracted one down here, I'm going to say that the angle is only about 34 degrees, give or take. Okay. And again, however you set this up, it might look a little bit different. Your numbers might be different than mine. On the next page, you're sending one from water to glass, and then you get to pick two different media. Be sure that you pick different ones. Don't use the same one for both, because it asks you about using the same medium for both on question number 12 right here. So don't skip and go straight to that. Okay, do two different things. From there on out, you're continuing to just kind of do more of the same, just follow the directions. At this point, hopefully you're familiar with the controls on the simulation. I've been talking for more than half an hour, so that's way too long. There's only a couple of you left over here. Does anyone have any questions? Let me unmute people. Race or Brenly, do either of you have any questions about this?
No.
Okay. Go ahead.
Random question.
Shoot.
So would the angle of refraction be different for stained glass? Like if it was stained, would it be different from normal glass?
That's a really good question. Off the top of my head, I really don't know. Let's see here. Does it give you the option in the sim of using stained glass? It does not. Race, I would assume that if it's stained glass, same kind of material, the only difference being that it's only letting certain colors through, would not be decidedly different. Just like which wavelengths of light, that's just a guess. I really don't know.
All right, I was just curious.
Okay, that's a good question. Anything else I can help you with?
Not that I can.
All right, well, I'm going to go ahead and draw this to a close. Race or anyone else who's watching this later, if you have any questions, leave it for me in the comments, Google Class, or on the Loom page where the video is going to be posted, or just, and I'll be in touch with y'all soon. Have a good afternoon.